So in the yesterday class, we were seeing about transaction management. So we continue with the same chapter even today. Uh, what did we do in the transaction management? So we continue. So what is transaction? So the transaction can be defined as a group of tasks. A single task is a minimum processing unit which cannot be divided further. Okay, so now I'll just ask you people, please log in. What is that? That is one transaction. I asked you people just to log in. I didn't say anything else. Can we split that word again further? No, it is not possible. Such type of things, such type of task is called as a single task or a transaction. So we can further divide. So let us take a small example and we move on. Let's take an example of a simple transaction. Suppose a bank employee transfers rupees 500 from an account A to account B. This very simple and small transaction involves several low-level tasks. So now let us see what are the transactions. So what is the task simple transaction we are doing? We are just transferring 500 rupees from an account A to account B. So now what we have to do, if what account A has to do and what account B has to do, account A, open account A. So first simple statement is we have to open the account. Yes, because we don't know for which account I have to deposit 500. So then I should know what is the account number, other details. So to know that, we have to say open account A. So then old balance equals to A dot balance. Then that's what A account is. New balance equal to old balance minus 500. So that's what A account is. So first we have to know what is a balance. What we are doing, so the bank transfers rupees 500 from account A to account B. So because I should know what is the old balance I have, because to add to that 500, I have to do some operation. What operation I'm doing? I'm doing an addition operation. So first I should know how much is in my account balance. Suppose if it is 1000 in the balance, now I have to add 500, then it should be incremented to a 1500. So that's what here, just see only transferring. The statement is only very simple. What is that statement says to us? Just transfer 500 rupees from account A to account B. This is only statement what we say, but think about what with respect to database, how the transaction, how many statement we require to process this. So that's what A account, open account A, then old balance equals to account A dot balance. Then new balance equal to old balance minus 500. So that's what A's account is. Then A dot balance equals to new balance. Then finally close account A. So this is what A's account will be done. What is that is done? Open account A, old balance equal to A dot balance, then new balance equal to old balance minus 500. Then A dot balance equals to new balance, then close account A. So what did we do? Oh, first open the account. I should know what is the account number of A. So that is open account and give the, so suppose if I say the account number is some, let me say like your USN number, some number, Allahabad bank number, let us say 500, 154, something like that. So then that account old balance, what is the account? Now we just told that it is 1000 rupees. The old balance will be from which account? From A account. So A dot balance is what? I'll get 1000 rupees in the variable called as a old balance. Then now what is our work? We have to add transfer. We are transferring rupees 500 from account A to account B. So now what I have to do? 100,000 rupees I have in A. Now from 1000 I have to subtract 500 because I have to transfer from account A to account B. So from account already what is the balance? 1000 rupees. Then deduct 500 rupees from that. So that's what old balance is 1000. 1000 minus 500 is what? New balance. So that's what new balance variable will be holding. So now after that, what will be the new value? What is the balance now? After you deduct 1000 from 1000 rupees, 500 rupees you are deducting. So then now my old balance, new balance will be 500 rupees. That's what A dot balance equals to 500. Then close account A. So I have to close the account what is there in A account. The next one is a B account. So in the B account, because I have to transfer 500 from A to B. So then I should know to which account I have to transfer 500. So then I should know what is B account. So if I say B account is some 155, then I have to first open that. So open the account B. Then what is the balance in the B account? Suppose if I say the balance in the B account is 2000. So then new balance equals to old balance plus 500. So old balance is what? New balance equals to old balance plus 500. What is old balance? Open account B. Old balance what I have 2000. Now for 2000 I have to add 500. That is new balance equals to old balance plus 500. So then B dot balance equals to new balance. Then close, because old balance is 2000. Now I have to add 500 to the already present account. So then what I have to add? I have to add 2000 plus 500. So now my new balance will be 2500. Then close B. So that's what here you can see. A's account and B's account, just a simple transaction. We are just saying one single statement, transfer 500 from account A to account B. That's all we say in the English. But think about the back end, how many coding we have to do. First, we have to open accounts, then first I have to check what is a balance, because I have to either deduct or credit. I have to add or subtract. I have to do one operation. So that is what new balance equal to old balance minus 500. Then A dot balance equals to new balance. Then close account A, A's account. Then B's account, open account B. Then old balance equals to B dot balance. Then new balance equal to old balance plus 500. Then B dot balance equals to new balance. Then close account B. So that's what here account A and account B. So this is what the transaction we are doing. Okay. So very important topic is acid property. What is this acid property? Definitely they will definitely ask in your placements, what is acid property? A transaction is very small unit of a program and it may contains several low level tasks. A transaction in the database system must contain atomicity, consistency, isolation, and durability, commonly known as an acid property, in order to ensure accuracy, completeness, and data integrity. So what is this acid properties? What do we mean by acid property? A transaction is a very small unit of a program. So what do we say about a transaction? Transaction, that's what I told. Smallest unit, what we say in our programming thing. A transaction is a very small unit of a program, and it may contain several low-level tasks. So it can contain, just now we saw one small transaction, transfer an amount from 500 from an account A to account B. So that's what we are seeing program, and it may contain several low-level tasks. A transaction in a database system must maintain atomicity, consistency, isolation, and durability, commonly known as acid properties. So what is this atomicity? We'll see one by one, but in the transaction of whatever we do with respect to database, definitely these four properties have to be maintained in the database. So my first property is the atomicity. Then second one is a consistency, then isolation, then durability. We'll see one by one, but before that, so for any database, you take any simple database, small database, or very big complex database, very big database, whatever it is, commonly this acid property should be followed or should be maintained in the database. In order to, why do we need to, you may ask me, why do we need to have this property? in order to ensure accuracy. So what is this accuracy? Now we say I am 90% accurate, 100% accurate, 97% accurate. In order to ensure accuracy, completeness and data integrity is ACID property. In order to ensure accuracy, completeness and data integrity. This is what is ACID properties. So a transaction in the database system must maintain atomicity, consistency, isolation and durability, commonly known as ACID properties, in order to ensure accuracy, completeness and data integrity. So first one, atomicity. So what do we mean by atomicity? What is this atomicity says to us? This property states that a transaction must be treated as an atomic unit. So we know in your physics you would have studied what is atom, a smallest unit, a small cell. That is what we told in the physics. That is what is called as atom. So the same way here with respect to transaction, we say it is a atomic unit, smallest unit. That is what is called as a atomic unit. That is either all of its operations are executed or none. So that is what is called as a atomicity. This property states that a transaction must be treated as an atomic unit, that is either all its operations are executed or none. What is this atomic unit says to us? So this property states that a transaction must be treated as an atomic unit, that is either all of its operations are executed or none. What is this atomic unit says to us? What is this atomicity property says to us is either you execute all the operations what I've told, or you please don't do anything. So that is an important property of this. Why? Because if half transaction, I cannot say half I have done with half transaction. No. So that is not acceptable. Either you complete the transaction or please don't do the transaction. That is what the atomicity says to us. There must be no state in a database where a transaction is left partially completed. There must be no state in a database where a transaction is left partially completed. State should be defined either before the execution of the transaction or after the execution or abortion or failure of the transaction. So what is the second statement says to us? There must be no state in the database where transaction is left partially completed. That's what I just told. You people say us in your lab, madam, my program is executed partially. So that is okay with respect to your lab thing, but we cannot consider that for your final exam. Either you have to completely execute or don't execute. That's what we say. Same way here with respect to transactions also. Either you complete the transaction, transfer amount 500 from A account to 500 B account. 500 withdraw and deposit. This should be completed. We cannot say I have withdrawn 500 from A. I will not deposit in B. No, that will not be accepted. So that's what is called as a atomicity, and that is what is a complete. We cannot say it is left partially. State should be defined either before the execution of the transaction or after the execution. State, whatever the state it is. So we have just seen in the operating system whether it is whether the operating system is started, whether it is running, whether it is waiting, whether it is in which state. So that's what state should be defined either before the execution of the transaction or after the execution or abortion or failure of the transaction. That's what here we see about atomicity. State should be defined either before the execution. State should be defined either before execution of the transaction or after execution, and either it may be about either you can stop, or sometimes it may be the failure of the transaction. Sometimes we say whether whether my network is not working, my server is not working, all these are the failures. So next property is consistency. So the database must remain in a consistent state after any transaction. So what is this says to us? The database must remain in a consistent state after any transaction. Consistency means what? So now you are in third semester. First semester and second semester results, if we see about the consistency, meaning of the consistency, suppose if your first semester is 80% and second semester is also 80%, then we say, okay, your studying for MCA is consistent because your first semester marks is also 80%, second semester marks is also 80%. Then we say it is consistent. This is a meaning of consistent. What is the meaning of inconsistent? Means, suppose if your first semester marks is 80 and your second semester marks is some 20%, then I cannot say it is consistent. I can say first semester you have studied very well and second semester you have not studied only. This cannot be there. Then we cannot say it is consistent. So what do we mean by consistent? Consistency, the database must remain in a consistent state after any transaction. The database must remain in a consistent state after any transaction. So you do any number of transaction, but the database should remain in a consistent state. No transaction should have any adverse effect on the data residing in the database. So that is what is a consistency. So no transaction should have any adverse effect on the data residing in the database if the database was in a consistent state before the execution of a transaction. It must remain consistent after the execution of the transaction as well. So that is what is called as a consistency. What is consistency? The database must remain in a consistent state. The database must remain in a consistent state after any transaction. So whatever I do. So today in the banking database, how many people will be using their account at one particular time? That at least we can see because of the net facility, internet facility, we may do any number of times opening of our apps, or we may close the apps. Then you think how many transactions per day the banking server has to do. Okay, whatever, how many number of times you do the transaction, how many people do use the server, but the database should be in a consistent state. So that is very important in the asset property with respect to transaction whenever we do the transaction management. So if the database was in the consistent state before the execution of the transaction, it must remain consistent after the execution of the transaction as well. That's what I say. If you how many times you open a banking app, so I may open 2 times. When I opened, the database state of my account should be same. Even it should be same even after I close my account. So that is what the statement says to us. Consistency means it should be same. My database state, if I am opened, that is open. So by my what is my balance of my account? Maybe some balance. After I close also, that balance should be consistent. Means whatever transaction we have done, that should be completed. So that is what is called as a consistency. So next is durability. How long the database should be present? So that's what, if we say banking, the banking definitely it should be there completely complete. And the durability we cannot say only for 1 year or 2 years. No. So with respect to banking database, it should be permanent. Whereas with respect to your shopping database, you can see Amazon or Flipkart, whatever it is. So maybe for 1 year, till their warranty is there, they may keep track of our details. That is what is a durability. Maybe suppose if you purchased a mobile and the warranty period given for the mobile is uh, 2 years, then we say it is a they may keep the database for 2 years because the warranty, because they give in that clauses, or they give the state saying that within the, if any damage or anything happened with the mobile within a warranty period, they will retain. So for that To maintain that, even they have to keep track the durability, means how many years the database of that particular purchased item should be there. So that's what the durability says to us. The database should be durable enough to hold all its latest updates even if the system fails or restarts. So suppose when we say you have downloaded some app, some application, let us say your SQL is downloaded, because to execute all your SQL programs you are executing. So then what we do is, uh, even after you download your SQL, your operating system should work fine. It cannot say I have failed. No. So even your, some people were saying me, my I have downloaded, but it is asking something. Means what, you have somewhere some steps you have missed. So that's what here. Once either you restart, either you download some apps, some applications, whatever it should work. So that is what it says. If the transaction updates a chunk of data in a database and commits, then the database will hold the modified data. So that's what here. You may have opened some Word file, or you may have opened your SQL and you have created two tables. So once you create a table, the two tables, if you have used commit command and if you have saved those two tables, then definitely in your database those two tables should be present. That's what here they say. Whatever the modified data I have done, it should be present. Same way your mobiles, they will keep track your details for 2 years. So for until 2 years, maybe, yeah, after 1 year, they have some problem. They bring the mobile to the showroom, and what changes you have done for that mobile should be kept in the database. So that's what here the transaction modified. So now you, after purchase, after 1 year, there was some problem, because the people who was manufacturing the mobile will know, will be modified, or will be having the knowledge for next products. So that's what here the modified data should also be present. If the transaction commits but the system fails before the data could be written onto the disk, then that data will be updated once the system springs back into the action. So that's how here the durability says to us. If a transaction commits but the system fails before the data could be written on to the disk, then that data will be updated once the system springs back to the action. So that's what here we are saving the file, saving everything. So that should be present. So that's what is called as a durability. And the last property here is isolation. So isolation is what in the database system, whenever more than one transaction are being executed simultaneously and in parallel, the property of isolation states that all the transaction will be carried out and executed as if it is the only transaction in the system. No transaction will affect the existence of the another transaction. What do we mean by isolation is, suppose if I say Asta is executing one program, first program, and even Anu is also executing first program. Asta is executing first program. Anu is also executing first program. So what the isolation says to us, Asta has to complete her one program. In the same way, Anu has to also has to execute first program. Same way in your lab exams also. Though you may get same programs, because it is exam, each one of you to execute its own. It is like your own program one. Same way here in the isolation, though you may have same program repeated, maybe 10 people out of 10 people in one batch, you may get 5 people got first program, but still each one have to individually execute the first program. So that is what isolation says to us. What the isolation says to us, in a database system where more than one transaction are being executed simultaneously and in parallel, the property of isolation states that all the transaction will be carried out and executed as if it is the only transaction in the system. No transaction will affect the existence of the another transaction. So that's what we have seen. So what is isolation? What is atomicity? What is durability? All these are the things in the database. So what is transaction says to us? Okay, so here, so we've just started with transaction, and we have seen how the transaction from one account to another account, it is being done. So we have just told transfer 500 from an account A to account B, and we have seen how the account A and account B transaction, just by saying a transfer 500 rupees from account A to account B, then that's how we are doing. So in the same way, next we have started with the acid property. What is acid property? A smallest unit in the program is called atom. And for that also, whatever the database we have, low level task, the database should follow or should have these properties, that is called as a acid property. So again, in this acid means what? A stands for atomicity, C stands for consistency, I stands for isolation, D stands for durability. So that's the reason it is called as an acid property. What is A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. This is what is called as a commonly known as a acid property. So why do we require this acid property? Because to ensure that accuracy, I should get my result accurately, and I cannot say I will do half and I will do other half late. No, you have to have a complete. That is what, to ensure that it is completed, completeness is followed, and data integrity. In one table, then suppose if I say the USN1 is Asta, in first semester USN1 is Asta, in second semester if I say Asta number is 10, no, it is not acceptable. So that is what is a data integrity says to us. Then we have started with the atomicity. So this property states that a transaction must be treated as an atomic unit. So what is this atomicity says to us? A transaction must be treated smallest unit. The same thing in your programming we say smallest unit. Same way here, atomic unit means smallest unit in the transaction. That is either, if I say atomicity, either you execute all operation or please don't execute anything. That's what is a atomicity says to us. Along with that, there should be no state in the database where the transaction is left partially complete. So I cannot say that today I will do half, tomorrow I will do half. No. So you have to complete. If you have taken one task today, you have to complete, then leave. So that is what is a atomicity says to it. In the same way, the state today is you've started one part. That please complete that. You cannot say half you'll complete today and half no. So you have to complete that task today. The state also define either before execution of the state and after the execution of the state, execution of any program or transaction should be same. So that's what here, transaction cannot be half. So next is consistency. So what do we mean by consistency? Consistency, a database must remain in a consistent state after any transaction. No transaction should have any adverse effect on the data residing in the database. If the database was in a consistent state before the execution of the transaction, it must remain consistent after the execution of all the transaction as well. That is what is called as a consistency. Consistency, that's what just now I told. Your first semester marks and second semester marks are 80-80, then we say it is consistent. If not, if your first semester result is 80% and second semester marks is 20%, then we cannot say it is consistent. It means you're not concentrating on your studies. So that is what we say about a consistency. Next, we see about a durability. So we've just seen what is durability. So how long your laptop may work, for 5 years, for 10 years. How much now you purchased your mobile. So how long your mobile will be working? What is the lifetime of your mobile? It will be there. Only the battery we have to change because we drop our mobile sometimes. There are so many things where the durability also matters there. So maybe 5 years we may use the mobile and it becomes old and we throw and we take a new one. So that is what is called as a durability. In the same way, with respect to database, how we have to keep. So now if it is a banking, lifetime or permanent, it should be there, because the transactions, what we have, when we have started, what we have started, what are the transactions, all should be recorded in the banking sector. Whereas with respect to some shopping. So till they have their warranty, they can keep their details. After warranty is finished, they may discard your database. So that's what is durability says to us. So the database should be durable enough to hold all its latest updates, even if the system fails or restarts. So whatever latest updates is there. So now suppose your operating system, what is our latest operating system, what is latest SQL. So we have so many versions. So now we start for a new version. So that's what here, even though I use a new version, my system should work as it is, the new version is being downloaded. If a transaction updates a chunk of data in the database and commits, the database will hold the modified data. What it says, whatever the latest one we have updated, that should be present. So that is what is called as durability. If a transaction commits but the system fails before the data could be written on to the disk, then the data will be updated once the system springs back to the action. So that is what is called as a durability. An isolation in a database system where more than one transaction are being executed simultaneously and in parallel, the property of isolation states that all the transactions will be carried out and executed as if it is the only transaction in the system. So that's what, no transaction will affect the existence of any other transaction. Isolation is, so that's what, you are 50 people, but I cannot combine every, so I cannot say Asta will execute one query, Anu will execute second query, third Pavitra will execute three. No. What is isolation? One complete program should be executed by Asta. One complete program should be executed by Anu. One complete program should be executed by Pavitra. So like this, each one is separate. So isolation. So I cannot say I will give 1 mark for Asta, I'll give 1 mark for Anu, I'll give, no. So I have to give complete marks. Whatever is there for your DBMS theory in lab marks, whatever you write, so based on that I have to give. That's what is isolation says to us. So in the next class, we start with the serializability, or we'll just touch upon it, what is a serializability, then we move on in depth in the next class. So what is serializability? When a multiple transactions are executed by the operating system in a multi-programming environment, there are possibility that instruction of one transaction are interleaved with some other transaction. Then we call it as a serializability. When multiple transactions are being executed, so now suppose 50 people, now in the same way in your internals, how is the internals? 30 people we are conducting in a 3 hours, but the same thing you can see with respect to your lab, because we want it to be accurately, we should see that no students speak each one of one to one. So that's the reason you can see only 10 people have been called for one batch. So that is what is multi-programming. Again, in 10 students, some of you may execute the same program. So multiple programming environment, there are possibility that the instruction of one transaction are interleaved with some other transaction. Sometimes I may say, you would have seen even in the lab exam, whatever the system you have taken, once you go out, it will be deleted, the program what it is. Because if we don't delete, the same program next person can execute, and he also will not be in a position to execute the program, because the first person has done wrong. The same, if the same system has been taken and same code has been used by the same person, then definitely he will also not execute. Instead of that, delete everything and redo first one. That is what serializability says to us. Serial means what? One after the other. One after this time, next batch. So in the same way, you can see there will be 3 batches. After one batch is completed, his 3 hours time is over. So next batch will be called. So again, next batch. But how? Based on your USN, based on your alphabetical order and USN given from the university, we have to follow that. First 10 people will be executed, next 10 people, next 10 people. Like this we take, that is what is a serializable. Then schedule. So just now I told schedule means what? So uh, uh, even now you can see the university will say when is the practical exam, when is theory exam, all this is what is this is called, this is what is called as a schedule. So a chronologically execution sequence of a transaction is called as a schedule. So now you have a schedule for your timetable. So Wednesday morning, first hour is DBMS, second hour is some other subject, third hour is some other subject. So Tuesday afternoon you have some lab. Wednesday also you have lab. Thursday morning you have lab. Like this, what is this? This is what is called as a timetable. The same way, even in your transactions also, we have a schedule. First, I have to execute this one. After this one. After this one. So this also will be followed in your transaction. That's what we call it as a schedule. A schedule can have many transactions in it, each comprising of a number of instructions and tasks. Now, your 50 students, I cannot say out of 50, 10 people can come to the first batch. No, are we calling like that? No. According to your USN, we are calling. So what is that? The USN means each one of you given a unique number. In that unique number, we say 1 to 10 first batch, then 11 to 20 some other batch. What we are doing? Each one is being given some task, some number. So only his time will be from this time to this time. So that is what is a schedule says to us. Then serial schedule, one after the other. After 3 hours is completed, we have to complete 10 peoples or one batch is over. Next, we have to start with next batch. So is what is this? One after the other. The same way, even in your database, one set of transaction is complete for this 1 hour or this 5 minutes or this half an hour. These many transaction is completed. Then we have to follow with the next transaction. That is what is called as a serial schedule. It is a schedule in which transactions are aligned in such a way that one transaction is executed first. When the first transaction completes its cycle, then the next transaction is executed. So that's what here, if it is a schedule in which transactions are aligned in such a way that one transaction is executed first. When the first transaction completes its cycle, then the next transaction is executed. Same way. If we start 8:30 one batch, so till 3 hours, that first batch will be given. Once first batch 3 hour is over, then we'll ask them to close, then we call the next batch. Same way here, if first transaction completes its cycle, then the next transaction is executed. So then transactions are ordered one after the other. Same way, your USNs is being ordered. First, we call first 1 to 10 USN, then 11 to 20 USN. Like this, we call, that is what is a transaction. Transactions are ordered one after the other. This type of schedule is called a serial schedule, as transactions are executed in a serial manner. Why do we call serial schedule? Because we give order, first 10 students, next 10 students, next 10 students. This is the order we have given. If you are 60 people, first day 3:30, next day 30, again in that 30 also we give which student has to come at 8:30, which students have to come at 11:30, which students have to come at 1:30. Like this we give. So this is what is called as a serial schedule. So I'll just stop here and we recap what we have done today. So we have started with transaction example, and we have told transaction can be defined as a group of tasks. A single task is a minimum processing unit which cannot be divided further. Let's take an example of a simple transaction. Suppose a bank employee transfers rupees 500 from A account to B account. This is very simple and small transaction, involves several low level tasks, that is A account and a B account. Open account A, old balance equal to A dot balance, new balance equal to old balance minus 500. So like this we say, that is what A account. So just only if we say in English like language, we have just told transfer 500 rupees from account A to account B. But think of the database, how many transactions we have to do with both the accounts. A account, remove 500, deposit to the B account. But for that, how many statements we are doing? First, we have to open, check the balance, what it is there, then subtract from A account 500, then update the new balance, then close. Then come to B account, open the account, check the balance, add 500 rupees, update this 500 rupees to new balance, then close. So this is how one transaction for both the accounts has been done. So then we have seen with the acid property, what do we mean by acid property? Acid means, the abbreviation of acid is atomicity, consistency, isolation, and durability. So this is what is called as a acid property. So then in order to ensure accuracy, completeness, and data integrity. So then what is atomicity? Smallest unit is called as an atomic unit. What is the functionality of atomicity? Either you execute all the transactions, or please don't execute. And if it is, there cannot be saying that I will execute on half today and tomorrow. No, that will not be accepted in the database. Then whatever state you are, the same state should be there once we do next. That is what atomicity. Then what is consistency? Consistency, it should remain the database in a consistent state. It cannot change or it cannot fail. So then what is durability? So durability, how many years, what is the age of this life? So the same way in your programming, we say scope of a local variable, scope of a global variable. Scope of a local variable means the function or the variable will be, means will have a life within only that function. Whereas if you say global variable, until the program complete, you can use it. Same way, durability, what is the database should have enough to hold its latest updates. So now in your operating system, what is the latest operating system is, or we can say what is the SQL latest version. That is what is a durability. Isolation. So you execute so many things at a time, but still each one has to be executed individually. That is what is called as isolation. Then we have seen about serializability. So when multiple transactions are being executed by an operating system in a multi-programming environment, multi-programming means what? Many. I may do 3 or 4 tasks at a time. Now you can see behind the thing I'm recording. I'm using a Google Meet. So 2 tasks. Along with that, I am using a PPT. Along with that, my voice will be recorded. See how many tasks, many tasks is being done at one particular time. So then that is what is called serializable. Now, out of this task, which one should be done first? Whether I can open PPT and I'll not open, I'll not record, or I'll not open Google Meet. No, there should be some order. First, I have to open Google Meet. After opening Google Meet only, I can record. After recording, I can share the screen so that every one of you see. So there is some serial, one after the other. So that is what is multi-programming. There are possibility that instruction of one transaction are interleaved with some other transaction. Then what is schedule? A chronological execution sequence of a transaction is called as a schedule. A schedule can have many transactions in it, each comprising of number of instructions or a task. That is what is a schedule. Then what is serial schedule? It is a schedule in which transactions are aligned in such a way that one transaction is executed first. When the first transaction completes its cycle, then the next transaction execution can start. So the transaction also are ordered one after the other. This type of schedule is called as a serial schedule, as the transactions are executed in a serial manner. Then stop here. We'll continue in the next class. Asta, answer your attendance. Asta.
Present, ma'am.
Yesterday you were absent, Asta. Abhinav? Abhinav? Why Abhinav is not turning up? Aishwarya?
Present, ma'am.
Ambarish? Ambarish? Anu?
Present, ma'am.
Arbaz? Arbaz? Even Arbaz is not turning. Arjun? ಅಶೋಕ್.
Present, ma'am. Ma'am, Arjun, ma'am.
ಹಾಕಿದ್ದೀನಪ್ಪ. ಬೆನಿಟಾ. ಬೆನಿಟಾ. ಭಾರ್ಗವಿ.
Yes, ma'am.
Last two classes, Bhargavi.
Ma'am?
Last two classes you didn't answer.
Ma'am, I
Bhavishya.
answered, ma'am. Some network issue I got, ma'am.
Bhavishya.
Present, ma'am.
Chaitra.
Present, ma'am.
Demalai. Demalai. Diksha. Deepika.
Present, ma'am.
Deepika.
Present, ma'am.
Deepika LG.
Present, ma'am.
Deepika MB.
Present, ma'am.
Murli Krishna.
Present, ma'am.
Gangubai.
Present, ma'am.
Gujiya.
Present, ma'am.
Harshit.
Present, ma'am.
Chunjar.
Present, ma'am.
Kavya.
Present, ma'am.
Kishore.
Present, ma'am.
Sir, sometime you are not there, sir.
Yeah.
Lata.
Yes, ma'am.
Yesterday. Yesterday,
ma'am. I was
Yeah.
absent, ma'am.
Yeah. Manisha.
Present, ma'am.
Manjunath.
Yes, ma'am.
Nayana.
Ma'am.
Ilanjan.
Yes, ma'am.
Nishant. Pavitra.
Present, ma'am.
Maithili. Maithili. Priyanka.
Present, ma'am.
Pavan.
Present.
Akash.
Present, ma'am.
Rajeshwari.
Present, ma'am.
Rakesh.
Present, ma'am.
Ramya.
Present, ma'am.
Rashmi.
Present, ma'am.
Ravi. Ravi. Rizwan.
Present, ma'am.
Vishal.
Present, ma'am.
Savita.
Yes, ma'am.
Shruti.
Present, ma'am.
Sneha.
Yes, ma'am.
Spurti.
Present, ma'am.
Srinidhi.
Ma'am.
Srinivas.
Present, ma'am.
Sunil.
Present, ma'am.
Vaishnavi.
Present, ma'am.
Vinny.
Present, ma'am.
Ma'am, Demalai present, ma'am.
Why
EVC 13.
why you didn't answer, sir? Every
Actually,
time
ma'am,
you don't answer, sir.
yes, sorry, ma'am, but my network issue happened. That's why, ma'am. In
Every
previous
time,
class,
every people will say the same thing. Network issue, network issue. Huh?
actually, ma'am, this time the meet was disconnected. When I am joining,
Yeah, I have given. People who
and
have
ma'am,
joined late can complete the quiz. I'm pasting the quiz link again. I'll wait for 1 or 2 minutes to complete your quiz. Then we'll stop. Just complete the quiz. Yeah, we'll stop. I will continue in the next class.